In this chapter, we want to look at special graphs, namely straight lines. We want to find out which type of equations have a representation as a straight line. So let's look at this straight line here. It is given by the point A with coordinates 1, 2 and point B with coordinates 6, 4. Let us now choose an arbitrary point on the line, point P with coordinates x and y. And we now want to find what we can tell about these coordinates x and y since it lies on the straight line. We start by drawing this right triangle here where one of these sides is parallel to the x-axis and the other side here is parallel to the y-axis, and its hypotenuse is the line AB, the segment AB. Now, how much is delta x? Well, delta x is just 6 minus 1, so 5. Delta x, this length here, it's from here, this coordinate here is 6, here we have 1, so this distance is 6 minus 1. The delta y here, this length is 4 minus 2, so it is 2. Why is it 4 minus 2? It's this coordinate here, the y coordinate of point B, minus the y coordinate of point A, 4 minus the 2. Delta x, delta y, we use that typically in mathematics to say a difference of something. So calling this delta x here means difference of the two x coordinates here. Delta y means the difference of these two y coordinates. Now, additionally, let's look at this delta x star and delta y star. So we have drawn the same type of triangle now for the points A and P. And delta x star is then the difference of the two x coordinates. So we get x minus 1. And for the difference of the y coordinate, we get y minus 2. Here, y minus the 2. This is this length here. These two right triangles here, they are similar. And so we know that the ratios are the same. This means the delta y in ratio to delta x, so delta y divided by delta x is the same as delta y star divided by delta x star. And the next step now is to insert the values we found here into this equation. So we get delta y is 2 divided by delta x being 5 is the same as y minus 2, that's the delta y star, divided by x minus 1. Let us get rid of the denominators, so we have to multiply by 5 and by x minus 1. And we get 2 times x minus 1 equals 5 times the y minus 2. Expanding this, we get 2x minus 2 equals 5y minus 10. And now let's bring everything to the left side. So we do minus 5y plus 10. We get 2x minus 5y plus 10 equals 0. And this here describes now our line L. So the line L, the equation belonging to this graph, to this line, is 2x minus 5y plus 8 equals 0. Let us now try to change it in a different form, namely in the form y equals to something. So the first step that we're going to do is we'll add plus 5y and we get 2x plus 8 equals 5y, and in the next step we just divide by 5 and we switch sides, so we get y equals 2x plus 8 divided by 5, and in the last step let's separate that, so write it as y equals 2/5 x plus 8/5. So that's our line L. We found two ways of representing it. One is to write it as 2x minus 5y plus 8 equals 0, or a second one, write the line as y equals 2/5 of x plus 8 divided by 5. So two possibilities of writing the equation of the line L. Now let's look at the general case. So the sketch is actually the same, but the difference is now I assume A just to be some point and B a second point through which this line passes. So the coordinates of the point A are just xa and ya, and the coordinates of this point B here are xb and yb. We proceed exactly in the same way as before. So again, we look at this triangle here, the small one, and then here the large one, delta x star, delta y star, and the hypotenuse AP. We know again that because the two triangles are still similar, no matter how we choose it, they will be always similar. So delta y star divided by delta x star is, because of the similarity, equal to delta y divided by delta x. Let us write down again what these different deltas are. So delta x is this distance here. So it's the difference of this coordinate and this coordinate. Then we get exactly this length. So this is exactly the coordinate of x coordinate of B minus the x coordinate of A. The delta y is this length here, which means it is the difference from here, this y coordinate minus this y coordinate. Well, that's the y coordinate of B and that's the y coordinate of A. Then we have delta x star and delta y star. Well, again, these are the difference for delta x star. It's the difference between this x coordinate, which is exactly the x, namely the x of P, and this x coordinate being the x of A. So I have x minus the x A. And the same holds for delta y star, so I have y minus y A. Y minus ya, this distance. Please note that here the xb, xa, and so on, all these are actually numbers. We just don't know them for the moment, while x and y, these are really variables because we choose an arbitrary point on this line here. So inserting what we found, we get delta y star is y minus ya divided by delta x star is x minus xa equals to the delta y, so yb minus ya divided by delta x, xb minus xa. So this equation here describes the coordinates x and y of an arbitrary point P lying on the same line as the points A and B. So this equation holds for any constellation where A, B, and P lie on the same line. Let's use what we found now to find the equation of the straight line passing through the points A minus 5, 2 and B 1 minus 10. As a small help, let's write here A, XA, YA and B, XB, YB. So we see now immediately what is XA, what is YA, and so on. So using now this equation here, we can insert everything. We get y minus ya, well, that's 2. Ya is 2, divided by x minus xa. Xa is minus 5, so I have x minus minus 5, and that equals yb. Yb is minus 10, minus then the ya, that's the 2, divided by xb is 1, again minus the xa minus 5. So minus 10 minus 2 divided by 1 minus the minus 5. So this simplifies to y minus 2 divided by x plus 5 equals minus 12 divided by 6. This minus 12 divided by 6 is just 2. So now let's multiply both sides by x plus 5, and we get y minus 2 equals minus 2x minus 10. Adding 2, we get the line in the form y equals something, namely y equals minus 2x minus 8. Or we can write it by getting everything on one side, by adding the right-hand side to the left one. So we get the line L is 2x plus y plus 8 equals 0. Let us now have a look at the result of example 1 and compare it with the result of example 2. Let's start with this result here. We found 2x minus 5y plus 8 equals 0. And here we found 2x plus y plus 8 equals 0. So we have both times a very similar structure. We have a number of x's plus a number of y's plus some constant equals 0. So we conject, vermuten, that we can write a straight line in the form ax, so some number of x's, plus by, some number of y's, plus c, some number, equals 0. The other solution that we found, also in example 1, here we found y equals 2/5 times x plus 8/5. And in example 2, we had y equals minus 2x minus 8. So what we actually found is y equals some number of x's plus some constant. So the other way of writing this is y equals, and now I use just m times x, y ever, plus q, just symbolizing again some number of x's plus a constant. Before proving that this conjecture is true, let us solve together the exercise 7.1 in the exercise booklet. We are given a line by its equation here, x minus 2y plus 2 equals 0. This means by its equation in the form ax plus by plus c equals 0. And our task in A is to transform this equation in the shape y equals mx plus q. So isolate y on one side. Try that on your own. Stop the film. And here comes the solution. We isolate the 2y by adding them. So we have x plus 2 equals 2y. And then we divide by 2 and switch the sides. We get y equals x plus 2 divided by 2, and rewriting it in the way that we like it, it is 1/2 x plus 1. In task B, we are given that these 2 points P and Q, they lie on the line L, here or here, and we should now find what are the coordinates, or the y-coordinates of these 2 points. So do it on your own, stop the film, and here comes the solution. Well, since P lies on the line, its coordinates fulfill the equation, we can use one of the two equations, this or this here. Well, it's obviously simpler to use this one here. So inserting its coordinates, we get yp, that's the y coordinate, is 1/2 times the x coordinate of p, which is 2, plus 1, and we get yp is 2. So we found the point P has coordinates 2, 2. We do the same for the point Q that lies on the line L. So we get yq, that's the y coordinate that we have to insert, is 1/2 times 4 plus 1. So we get 3. So the point Q has coordinates 4 and 3. Now in task C, let us draw these 2 points P and Q in this coordinate systems, and once we have the 2 points, we can also draw the line L. Do that on your own, and here comes the solution. In task D, we have to draw this right triangle with delta x and delta y using the points P and Q, as we have seen in the theory. So do that again on your own. Here comes the solution. Task E is to find the proportion delta y divided by delta x and compare it with the parameter m in our equation. You remember the parameter m, that's the y equals mx plus q. So that's this form. So mx plus q, we have 1/2 x. So the m is 1/2. So solve the task on your own, and here comes the solution. Delta y is 1 here, it's 3 minus the 2, and the delta x, we can read it off, it's 2, it's the 4 minus the 2, so we have delta 1 over delta x is 1/2. And as we said before, the m, we can read it off from the equation here, so the m is 1/2, 2. So what we actually see is the m is delta y divided by delta x in this case. In task F, we're given the point R with coordinate x coordinate being 0 and y coordinate yr. This point lies on the line, and we should find now yr and then compare it to q again using this equation here. So do that on your own, and here comes the solution. R lies on the line, so we can insert its coordinates into the equation here, for example. So we get yr equals 1/2 times the x coordinate, which is 0, plus 1. So we get 1. We should compare that with the parameter q of the line, y equals mx plus q here. So q is just 1. So we have q is 1. And looking at this, we see that q is actually just the y coordinate of this point R of the point with x coordinate 0. Okay, so now let us return to the proof of our conjecture. We have shown that for the coordinates x and y of a point P lying on the line passing through the points A and B, this equation holds. So this is the equation of the line passing through the points A and B. Now, first step, let us get rid of the denominator. So we multiply with x minus xa and xb minus xa. So we get this equation here. Now we expand this equation, or we expand the expressions on the left and the right hand side, and we subtract now this expression on both sides. So we get minus yb minus ya times x here on the left side. On the right hand side it disappears. And we keep this part here, and we expand this expression. So we get this here, and this expression over here, we get this here. And in the last step, we subtract this whole expression here. Or in other words, we add xayb and subtract xaya, so the right-hand side becomes 0. The plus xayb is here, minus xaya cancels out, So what remains is here xa yb minus xb ya. And this here, ya minus yb, since the 2 points A and B are given, so also YA and YB are just numbers. So YA minus YB is just another number, and we call that number A. The same holds for XB minus XA, that are the x coordinates of the 2 given points. So again, 2 numbers given. So this is another number, let's call it B. And we have the same situation here. Again, XA, YB, XB, YA are all just numbers. So in the end, we get another number, C. So what we found is that if L is a straight line, we get an equation of the structure A times X, something times X, plus B times Y, something times Y, plus C equals 0. To get the other form of the straight line, we just look again at this equation here and we subtract now this expression, so minus ya minus yb times x, and this expression minus xa yb minus xb ya, and we get this expression here. In the next step, we divide now by the factor in front of the y, which means we divide by xb minus xa, and we get this expression here. And now we do the same thing like before. Again, xa, xb, ya, yb are just numbers, so this expression here is just another number. We call it m, and the expression here after the minus is also another number, so we call it q. And we see the expression for the straight line is y equals mx plus q. There is one exception where a line cannot be represented in this form, namely if xb is equal to xa. Well, we see that here. We have divided by xb minus xa, and remember we're not allowed to divide by 0, so that would not function if xb is equal to xa. So we have proved our conjecture. A line L can be, its equation can be written in the form ax plus by plus c equals 0, or y equals mx plus q.